This coin has been dropped 10,000 times, rubbed against keys, soaked in sweat, left in the rain. Zero rust, zero cracks. The best of your steel tools can't do that. Steel rusts in weeks. Aluminum corrodes. Copper turns green. But this quarter from 1975 still works in vending machines. The secret isn't what it's made from, it's how it's forged. Before I reveal the engineering trick, comment which metal you think lasts longest. Copper, nickel, or zinc. I'll tell you why you're wrong in 60 seconds. Coins face chemical warfare daily. Sweat acids from 10,000 hands. Chlorine from washing machines. Impact forces up to 50 Gs when dropped. Temperature swings from 20 daggers to 60 daggers. Pure iron, rusted in 48 hours. Pure aluminum, oxidized and pitted. Pure copper, green patina everywhere. So how do coins resist corrosion? Coins aren't metal, they're engineered alloys. 19.67% copper plus 8.33% nickel bonded to a pure copper core. Here's why that ratio matters. Copper provides ductility. It bends instead of shattering. Nickel creates a passive oxide layer that blocks moisture. The bond prevents galvanic corrosion between dissimilar metals. This is the same cupronickel alloy used in marine propellers, desalination plants, and submarine hulls. It's designed to survive salt water. Your pocket change is overbuilt, but the alloy is only half the story. Watch what happens when raw metal becomes money. 200 tons of pressure slams down in 0.02 seconds. This does three things. It compresses the crystal lattice structure, making it 3 times harder than the blank. It fuses the nickel cladding to copper core at the atomic level. It creates surface residual stress that resists crack propagation. That single impact gives coins the hardness of low-carbon tool steel. Quick question, how many times can you bend a coin before it breaks? The answer will shock you. Keep watching. See these ridges? They're called reeding. Most people think they prevent counterfeiting. Wrong. They're crack arresters. When a coin hits concrete, impact force concentrates at the edge. Smooth edges develop stress risers, microscopic cracks. Those cracks propagate until the coin splits. Reeded edges distribute impact force across 119 individual ridges. Engineering term, multi-point load distribution. It's the same principle used in aircraft turbine blades, bulletproof glass layering, and bridge suspension cables. That's why 200-year-old coins still survive. Remember that question? How many bends before failure? Pure copper, 12 bends. Pure nickel, 8 bends. Coin alloy, 47 bends before first crack appears. Why? Grain boundary engineering. The strike process creates microscopic grain structures that deflect crack paths. Every time the metal wants to fail, the grain boundaries force the crack to change direction. It's not stronger metal, it's smarter metal. After thousands of impacts, after decades of corrosion attempts, it still passes every test. Because coins are built to outlast governments, currencies, and empires. Money is infrastructure, designed for 50-plus year service life. So can coins rust? Answer, yes, but only under extreme conditions. The next time you hold a coin, you're holding a piece of material science that has survived more impacts than a car bumper, resisted more corrosion than ship hulls, and outlasted governments, wars, and economic collapses. It's 24 millimeters of engineered immortality. Small, ordinary, unstoppable. This is how it's forged. If you want to know why paper money is actually stronger than cloth, or why credit cards don't snap, subscribe. Because what's hiding in plain sight is always more fascinating than you think.